Okay, except okay, now you have to study about I mean, now what you have to do is you have to study you have a slightly more difficult questions related to moles. Okay, that's what you're going to do with this. So the first topic is going to be moles and stoichiometry. And before moving to moles and stoichiometry, what you need to do is you need to learn about equations. So I'm going to write all the equations first that you have studied in your O levels. Okay, and I'm going to write all the equations which would be required, which would be needed. We're going to practice those equations as well. Okay, one by one. But just for a brief recap of what we are about to do, this will give you an idea of what the end goal is. So we're going to start with the first equation, number one. Okay, I'm just going to write all the equations. The first one is metal plus acid, and this one produces salt and gives off hydrogen H2 gas. That is the first one. The details will come later. The second one is a metal oxide or a hydroxide reaction. I mean, that could be a hydroxide as well. Or you could have NH4OH, any hydroxide. So these react with acids and they produce salt and water. Then you've got a third reaction, and the third reaction is a carbonate. That could be a metal carbonate or ammonium carbonate. Or it could be NH4 twice CO3, ammonium carbonate. It reacts with an acid to produce salt, water, and carbon dioxide. Then you've got a fourth one. The fourth one is an ammonium salt, or let's talk about ammonia reacting with an acid, and it produces an ammonium salt. Now, if you've done your O levels, you've done most of these reactions. Okay, remember, I'm going to do each one individually. Number 5 is that if you have an ammonium salt, then it reacts with bases to produce salt, water, and ammonia. You did all of these reactions. Number 6, there was a reaction called ionic precipitation. Just don't get worried about this. I'm going to do each one individually. Just writing this so we can have a summary of the reactions that we have to do or cover during revision. And remember, equations are the most basic things. Equations must be on your fingertips. You should know, like if somebody tells you that there's calcium phosphate, you should know what calcium phosphate is. If somebody says that there's aluminum carbonate reacting with sulfuric acid, you must know how to write that equation and balance that equation. As anyways, we reached ionic precipitation. Then you have carbonates decomposing. So metal carbonate would decompose. And it will produce a metal oxide. And it will produce a carbon dioxide molecule. Then you've got another reaction, which is metal nitrates. They also decompose. And they produce metal oxides plus they produce NO2 gas, and they produce O2 gas as well. Group 1 nitrates kind of decompose differently. That they produce metal nitrites.
Sir.
Assalamualaikum. Assalamu alaikum. Plus O2. I said number 9, you also did in O-levels a reaction where you had metals reacting with water. And when they react, they will produce metal hydroxides, like sodium reacting with water. And hydrogen gas was given off. What else? You did displacement reactions. Like a more reactive substance would displace a less reactive substance. I said anyway, so and there was decomposition of hydroxides as well. So metal hydroxide would decompose, and it would decompose to form a metal oxide plus water molecule. So I think that's enough for now. So we have like 11 reactions which you studied in O-levels. Metal plus acid, base plus acid, carbonates plus acid. So you need to know each one of them. They should be on your fingertips. You should know how to make those reactions, etc. So I'm going to start with the very basics. Okay. So this is just the summary of what we're going to target. Okay. Before actually starting moles, remember all of these reactions are very basic. I mean, they're one of the most fundamental things. Like, I mean, if you're doing a question, I mean, most likely you'll not get any direct questions on making an equation. I mean, that time is over, okay? But the whole question might be dependent on your understanding of that equation. Like if you don't know how that equation is balanced, if you don't know what the products are, so the reactions are, I mean, these reactions are some of the most basic reactions that you need to know at all costs, because if they come and they will come, I mean, they usually do come in every question. And if you don't know what the reaction is, you won't be able to do all the rest of the question as well, and all the other parts as well. Okay. So is this clear? You're familiar with these reactions, right? We're going to start studying them Okay, we're going to start studying them one by one, but we're going to start with the very basics. And the very basics are, we're going to talk about formulas first. Like how do you form formulas? And we can start off with ionic compounds. So we can start off with formulas of ionic compounds. Now ionic compounds have a metal. I'm sure most of you know they've got a metal and they've got a non-metal as well, right? And what usually happens is that the metal loses electrons and the non-metal, it gains electrons. Okay, this is what's going on. It forms a positive ion. The other one forms a negative ion. So I'm going to take a sodium atom. Let's say there is a sodium atom. Sodium, I think, has 3 shells. Just one second, let me draw those shells one by one. Not this, not this. So I've got a sodium atom. That's shell number 1, and that's second. So that's shell number 2, and it's got a shell, a third shell as well. Yep. So that's what sodium is. It's got 3 shells. Just doing one dot and cross diagram. I'm not going to do more than one. TK, that's something that's very basic that you did in O-levels. So sodium and Cl. Sodium, remember, has 11 protons in its nucleus, so that's 11 protons. Cl, on the other hand, has 17 protons, and it's got 17 electrons. So sodium over here has 2 electrons in the first shell, 8 in the second one. And there's 1 electron in the last. So that's your sodium atom. Cl, on the other hand, has 2 electrons in the first shell. It's got 8 in the second, and it's got 7 electrons in the last one. So 2, 8, and now tell me what's going to happen. Who's going to lose electrons? Who's going to gain electrons? What's going to happen? You've got sodium and you've got Cl. Anyone?
So sodium will lose electron.
Okay, so sodium will lose electrons, and that electron would go to Cl. Okay, so this electron would go to Cl. Sodium will lose, eventually lose its entire outer shell. There's nothing there, so I'm going to just remove that. And chlorine will gain. Okay, Zainab, that's correct. So sodium would lose electrons, sodium would become +1, and Cl would become -1. So that's it. And that's what an ionic compound is. Okay, that's your formula. It's NaCl. Na is +1, Cl is -1. Okay, together, overall, they're not going to have a charge. So the positive and negative charges will cancel out. I mean, overall, it's not going to have a charge. Like if you think of this whole thing, it's not going to have a charge. But sodium will have a +1 charge, Cl will have a -1 charge. So this is NaCl. Okay, you already know this. Why do first thing? Just a brief background. Why is this losing electrons? Why is this gaining electrons? Remember, metals are on the right side of the periodic table, left side, and they have this tendency to actually lose electrons, and non-metals have this tendency to actually gain electrons. So I'm going to just briefly talk about this, why metals lose electrons, why non-metals gain electrons. Like if I have, let me just open a periodic table. So let's look at this old O-levels periodic table for a second. Okay, remember you'll have as this one. So the question is, why are metals losing electrons? Why are non-metals gaining electrons? So here's our periodic table. I'm just going to copy this, paste this over there. And let me add a page. As this one. So here's the periodic table. Now the question was, what is the trend? Why do metals are on the left side? Non-metals are the ones that are on the extreme right. So those are your non-metals on this side. So these elements over here, these are your non-metals. These elements over here, these are your metals. Usually there's this thin dividing line that's around boron. There's a staircase, and around boron you've got I mean, on the left side, most of the elements are classified as metals, and on the right side of the staircase, most elements are classified as non-metals. They like to gain electrons, they like to lose electrons. But remember, the boundary is not that sharp. It's a gradual change. You move from metals to non-metals. When you move to the right, you develop this tendency to gain electrons. I mean, they like to gain electrons. And these they like to lose electrons. But it's a gradual change. It's not like there's this very sharp boundary. It's not I mean, if you want to classify them, you'll classify them these as metals, classify the other side as non-metals, but it's not a sharp boundary. It's going to be a gradual change from metals to non-metals. Is this point clear?
Yes, sir.
Achha, so it's going to be a gradual change. Achha, why is there going to be a gradual change? The ones on the left side are very reactive. They like to lose electrons a lot. I mean, they're very reactive. Okay? For example, sodium is very reactive. As you start moving to the right, the tendency to lose electrons diminishes. It decreases. Like copper is very unreactive. Like if you look at copper, I mean, you make wires out of copper, okay? For 30 years, for 40 years, wires are in your, I mean, most of the electricity in the house is running on those wires. It doesn't react. It doesn't lose electrons. Similarly, you've got gold over here. I mean, gold doesn't like to lose electrons. So when you move to the right, the tendency to actually lose electrons, it kind of diminishes. It decreases. I mean, platinum is very unreactive. So platinum doesn't like to lose electrons. And as you keep moving towards the right, the tendency to gain electrons kind of increases. I mean, you've got iodine, it becomes -1, it gains electrons. Bromine becomes -1, chlorine becomes -1. So there's this gradual change. These ones on the extreme left, they really like to lose electrons. These ones on the extreme right, they really like to gain electrons. The ones in the middle are kind of in the middle. Gold doesn't really like to lose electrons. It will, if it were to form an ion, it always forms a positive ion, never forms a negative ion, but it doesn't really like to form the positive ion. It doesn't really like to lose electrons. Okay? Is this point clear? Siddha, is this clear? Zainab?
Yes.
Amna, is this clear?
Yes, sir.
Achha, so the point is, this is why these are called transition metals, because they kind of, I mean, some of them are kind of in the middle, and you've got lots of metalloids as well. Now the point is, why is this happening? Why do the right side? Why these elements wanting to gain electrons, and why the elements on this side wanting to lose electrons? The reason is very simple. The ones on the left side, for example, if you pick any row, lithium has 3 protons, fluorine has 9 protons. Okay, for example, if I mark this, I've got fluorine over here, and I've got lithium that's over here. So lithium just has 3 protons. Fluorine over here has 9 protons, right? So that means the nuclear charge right in the middle, lithium has just 3 protons. It has a +3 charge, and fluorine has +9 proton, like 9 protons. So the positive charge is a lot. So imagine that there are no electrons around them, right? Imagine the shells are completely empty. Just look at the nucleus. Which one has a greater tendency to attract electrons? I mean, this one has a much higher positive charge. In the nucleus. So there's obviously going to be more attraction for electrons. Not only is there going to be more attraction, there's going to be a stronger attraction for electrons.
Yes.
Because so it's going to have a very strong attraction for electrons. This one is not going to have a very strong attraction for electrons. So this is what happens when you move to the right. The elements on the left side, they don't have a lot of protons. The elements on the right side, they have a lot of protons. So obviously they have this strong attraction for electrons, and they would tend to gain electrons. And these ones would tend to lose electrons because their nucleus isn't positive enough. Is this point clear?
Yes.
Okay. Raid, is this clear? Sidra, Zainab?
Yes, sir.
Yes.
So that's the first thing. There's a trend. They like to lose electrons. They like to gain electrons. The middle ones are kind of like somewhere in the middle. So coming back to this, one thing, okay, let's write it over here. One thing you've learned about ionic compounds is, which you've already learned, and that is that group 1 has a charge of +1. Group 2 is going to have a charge of +2. Remember, it's ionic compounds. It's a metal and a non-metal, right? You've got transition metals. So now instead of using the word transition metals, I'm going to call them D block elements. I mean, that's a more proper term to describe the transition metals, okay? Because the problem with transition metals is that transition metals, not all of them are transition metals actually. Like the middle one over here, in the box over here that's in the middle, not all of them are transition. Most of them are, but not all. For example, zinc is not a transition metal. It doesn't form colored compounds. It doesn't have variable oxidation state. It's not a catalyst. Scandium is not a transition metal. So the proper term is D block elements. Okay, so make sure you start using this term instead of transition metals. I'm going to explain that later on. Okay, but for now, start using this term. So then you've got group 3, you've got group 4, you've got group 5 and 6, and there's group 7. And finally, now these groups are for in the new periodic table are called 14, 15, 16, and 17. And the last one is your noble gases, that's 18. Remember, there's no difference except that instead of calling it 3, you just call it 13. So instead of calling group 4, you start calling it group 14. So now these ones you have group 3 will have a charge of +3. As a similarly, group 4, what charge would group 4 have?
+4.
As it could have both +4 or -4. Group 5, tell me the charge of group 5.
There's charge of 5.
No, group 5 has, it's a non-metal. It would start gaining electrons. It's got 5 electrons in its outer shell. How many would it need to fill its outer shell?
3.
So it's going to be -3, and this would be -2. TK, and this one would be -1. TK, is this clear? These are non-metals. I mean, non-metals start at group 4. And the ones on the left side are mostly metals. So remember the charges on the elements. Now, when an ionic compound is formed, there's going to be a positive ion. So there's going to be one metal ion from this side. I mean, this entire side. And there's going to be one non-metal ion. So let's say I have magnesium, which is in group 2, and I've got nitrogen, which is in group 5. So Mg is going to have a charge of +2. Nitrogen is in group 5, it's going to have a charge of -3. So the two things are going to attract each other. +2 will attract, the negative ion will be attracted to the positive ion. They'll join up. So can you tell me what's the formula of this compound?
What's the formula
Of this, like if they join up, what's the formula?
Mg3 and 2.
Okay, so this one, yes. So remember in O levels, you have studied this. That's basic crisscross. What happens is that this 3 goes over here and this 2 goes over here. If anyone has any questions about this, is this clear?
Yes. Yes.
So it's going to be Mg3 and 2. That's going to be the formula of this ionic compound. Okay, that's known as crisscross. You always do that. And the reason for that is crisscross is just a shortcut. The explanation for that is that why do you need to do this? It's simple that Mg is losing how many electrons? It loses 2 electrons. I mean, it's got a charge of 2+. Nitrogen is gaining, it's got a charge of -3, so that means it's gaining 3 electrons. Now, the number of electrons that Mg is losing, I mean, this is what was happening over here, like sodium and Cl. The number of electrons lost by sodium must be the same electrons that would be gained by Cl, right? If sodium loses 1, Cl gains 1. So the electrons lost and gained, they must be equal, but in this case, they're not equal. So how do you make them equal? Instead of having 1 Mg, you have 3 Mgs. So if you have 3 Mgs, the total electrons lost would be 6, right? And instead of having 1 nitrogen, you're going to have 2 nitrogens. If 1 nitrogen is gaining 3, 2 of them are going to gain 6 electrons. So the 6 electrons becomes equal to 6 electrons. That means in total there are 3 Mgs and they're losing 6 electrons. In total there are 2 nitrogens and they're gaining 6 electrons. So now the number of electrons lost and gained are equal. Is this clear?
Okay. Yes.
But the simple thing is you don't have to like discuss this. I mean, the shortcut is just bring the 3 over here and the 2 over here. I mean, this thing would sort itself out. You just have to do crisscross.
It's for confirming.
Huh?
It's for confirming the answer.
I mean, which thing? This thing?
Yes.
This was, I was just confirming whether we did this right or not. I've got 3 mgs and 2 nitrogens in the formula, right? So it makes sense. There should be 3 mgs and 2 nitrogens. Is this point clear?
Yes.
But from now on, you don't actually have to do this. You just do crisscross. That's it. You just get the formula, right? And you can figure out the charges of the ions from the table. So I'm going to do another one. Let's say I have aluminium and I've got fluorine. So what's the formula? Now, aluminium is in group 3, so it has a charge of +3. Fluorine, on the other hand, is group 17. It has a charge of -1. So what's the formula for this?
AlF3.
So it's just to crisscross. There's going to be 1 Al. You don't have to write 1. I mean, even if you write it, there's nothing wrong with that. So that you're right, it's Al and F3. Okay. So is this clear?
Yes.
So what about Al and O? Now Al is +3. O is in group 6. So that means it's going to be -2.
A2O3.
Okay, so this one is going to be Al2 and O3. So that's the formula of the ionic compound. And then how do you write the names of these ionic compounds? It's got 2 ions. It's got magnesium and it's got nitrogen. They're 2 ions, Mg and N. So you've got magnesium. And you've got nitrogen. Now the only difference is that the name of the negative ion changes only. When you name this thing, instead of calling it nitrogen, you call it nitride. That's it. Same thing over here. This is aluminium and fluorine. So instead of calling it aluminium and fluorine, so you don't call it fluorine, you just add ID at the end, you call it fluoride. Similarly, this one is aluminium ions and oxygen ions. So instead of saying aluminium and oxygen, the end or the suffix changes, it becomes IDE. Okay, is this clear?
Yes. Yes.
Yes.
And the same thing over here, we did sodium and instead of calling it sodium chlorine, it's sodium chloride. So it's something very basics, but a lot of people mess this up. Make sure what does IDE represent? 1 second. So make sure what's the meaning of IDE. So IDE is added to IDE is the negative ion of an element. For example, if I say phosphide, what does that mean? What does that represent?
That it has a negative ion.
Yeah, but it's just going to be phosphorus, and phosphorus is in group 5, so it's going to have a charge of -3. If I write sulfide and it has ID at the end, then it's only going to be sulfur, nothing next to it. It's going to be -2. A lot of people, what they do is they confuse this with phosphates and phosphites. Remember, IDE is different. IDE is just the element. If I write bromide, so bromide is going to be Br and it's in group 17, so it's going to have a charge of -1. If I write carbide, then it's going to be just C and it's in group 4, so it's going to be -4. Okay, is this point clear?
Yes.
Yes.
Okay, and just to differentiate, this is not phosphate or phosphite. Like phosphide IDE is different. When a T comes in, that indicates, like when it's an 8 or an 8, that means it's with oxen now. Okay, we're going to discuss these ions later on. But keep this separate. Okay, I mean, make sure you differentiate. Like if calcium phosphide is written, then it's just phosphorus. That's it. Just hold on one sec. Sorry. Is this point clear?
Yes, yes, yes.
Just make sure, okay, what does ID? Whenever you hear iodide, that just means iodine. That's it. It's the negative ion of iodine. So this one second. So this one is an important point. Just a second. Let me. Okay. So this one is kind of an important point. And you should know about this. As anyway, so the first exercise that I'm going to do is I'm going to just write random elements. Okay, just something very basic. All you have to do is make sure that you know how to write the formulas. So, for example, you've got like Na and P. Okay, tell me what the formula is and name it as well. Second one, I've got this is Na. One metal, one non-metal, Mg and S. I've got Ba and N. You open a periodic table, find out what they represent. Ca and F. Number 5 could be aluminium with sulfur. Potassium with nitrogen. Okay. So try and do all of these. Okay. I'm just making a Google Classroom for this. And I'm going to post this in the... And name them as well. Okay. You have to name them as well. Just one second. As I'm posting it, just a second. I forgot where's the group? Can somebody miss this one? So this one, I'm going to make a Google Classroom for this. Post the assignment in the Google Classroom. Okay. So
Okay, sir.
let's continue
I'll take a picture.
tomorrow. Okay. Okay. Take care.
Okay, then.
Okay, sir. Allah.
Okay, sir. Allah.
Hafiz.
Okay.